So, as I mentioned in the previous video, one of the most popular algorithms for clustering is known as k-means. It's also very intuitive, actually. It's very easy to understand when you see it in action. So k here refers to the number of clusters that you want, and you have to choose how many that is. So it won't decide how many for you. And the mean means just the interpretation of that is that it moves the center of the clusters to the mean or the average value of the data that's in that cluster. Okay, so it's just talking about k is the number of clusters, mean is the average value of the average position of the cluster. And the algorithm goes as follows. And I think while I'm explaining it, it's probably easiest to think about this in 2 dimensions. So if you imagine your data, just imagine it's 2-dimensional data. Imagine it's randomly, or no, not randomly, imagine it's placed in a scatter plot. So we've got the 2 dimensions, one against the other, placed in a scatter plot. And if you think about that, what we can then do is take our k centroids, so the k centers of the clusters, and we can just randomly place them in that 2D square in the scatter plot. Then you take each data point in turn and attach it to its nearest centroid, and that's visually that's quite easy to see usually, but you can obviously measure the distance between each data point and all the centroids and attach it to the nearest one. And then the centroids, and this is where the mean comes in, the centroids are moved to the center of all their attached data points. So just because we've attached a load of data points to them, that doesn't mean they're in the middle. So we take the centers, these k centers, and we move them to the center of each of all their attached data points. And then you just iterate that procedure. So every time we move a center, that means some new data points will get attached to it, some old ones will not get attached to something else perhaps. And so that once we've done that attaching, then the center of the cluster will get adjusted again slightly. And it tends to be the case that the cluster centers move quite a lot at the beginning of the iterations and quite slowly at the end. So they make very small changes as we just adjust the positions and the clustering. So it's an iterative technique. It usually runs, in maybe 10, 15 iterations, it will have finished doing its job. And I think the easiest way to understand it is to have a look at an example. So here's an example. You can find quite a lot of these videos on YouTube. This is just one that I picked. It's got some nice music, which I'm not going to play for you because I'm going to talk over it. But if you want to hear the music, go and visit the page. So there we've got some random data scattered over the 2D plane, and we randomly place the centers. And we then assign the data to their nearest center. And then the centroids are moved. The means they're moved to the mean of the cluster. And then we attach again the data to its nearest centroid, and then we move the means again. And then we keep repeating that process. So we attach, then move, and you'll see they're moving very little now. We attach, and by iteration, this is going to be iteration 4. By iteration 4, the centers move very little. Okay, I'm not going to finish that off. You can watch that yourself if you want to. So that's how the algorithm works. And although we can think about it in 2 dimensions and it's easy to understand in 2 dimensions, actually it will work in multiple dimensions. So let's actually apply it then. So here's a set of data set that we're familiar with. We're going to do some clustering on this initially to try and make sense of how it works. This is the summary data from the products, and this is the marketing and sales variables. We're just going to cluster the marketing and sales variables, or cluster the data based on the marketing versus sales. Okay, so it's going to be easy to interpret because we can visualize that in 2 dimensions because we've only got 2 dimensions to look at, marketing and sales. Okay. I've chosen k to be 4, and I've chosen those 2 variables to cluster on, and then I can create a k-means object from the library, from the scikit-learn library, and then this line in bold actually does the k-means clustering. And what that does is we give it the data we want it to cluster, and it returns a list of labels. So each each row in that data gets labeled into a cluster, which the cluster will be either 0, 1, 2, or 3. 0, 1, 2, or 3. So the numbers up to 4. So if you did it up to 10, the numbers will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So that will give us an extra column for our data frame, which I'm calling label. And then in these 3 lines of code, I just put I create data frames, separate data frames for each cluster. So what I do is I pick I loop over the values of 0, 1, 2, and 3. So if you're not too familiar with Python, range k gives you the values up to the value you give it. So if I give it 4, range 4 will give me the values 0, 1, 2, 3. I loop over those 4 values. C is going to become 0, 1, 2, and 3 each time around the loop. And clusters is going to be a list. And each time around the loop, I get that cluster, the corresponding cluster. So first time around the loop, C will be 0. I get the data corresponding to the 0 cluster and put that in a data frame. So that's a data frame, and then I append that to the list. So I get 4. This list will contain 4 data frames, each containing a cluster. Okay, now we just need to visualize them, and to do that I can use the scatter plot techniques we used before, but now I'm going to sorry about that. Now I'm going to scatter the each cluster one after the other, so that they come up, each cluster, the data for each cluster will come up in a different color. So by doing this loop 4 times, I'll get each cluster will come up in a different color. So I'm clustering the particular cluster with their marketing and sales values. And then this loop here, the next loop is just to label the cluster, label the data points, so I know which one is in which cluster. Okay, and if I do that, this is the picture that I get. So, and you can see it's, because we're doing this in 2 dimensions, usually the clusters will make sense in 2 dimensions. And you can see that it's picked a cluster up here, an orange cluster up here, a green one here, a red one there, and a blue one there. So what's it done? Without knowing anything about the data, it's actually picked all the high volume products. Those are the orange ones, AF and L. I don't know if you can read those labels, but they're AF and L. All the medium volume products. So it's actually segmented quite nicely down through the sales. So it's given us the top segment, which is the high volume. It's given us the medium one. And then it's got the red cluster is low and very low volume products, but those with a high marketing spend. So anything above, say, about 15,000 marketing spend, there's 10,000, there's 20,000, so there's 15,000. So anything above that, but low and very low volume is put in the red cluster. And so the blue one is low and very low volume products, but with low marketing spend. So those are the clusters that it's found for that particular data set. Okay, I'll finish that video there. That was a sort of motivational example, and then we'll look at how we decide how many clusters we're going to use.